3, the decay was about 12 points. And because of this, we end up shorting 6 contracts. And the gain or loss for this specific example was a loss of $2,000, which does sound bad, but this is, 6 periods and 9 periods out of 39 periods for each factor. So the gain loss ends up being pretty balanced overall, which is what we were looking for. And then just for more context, say for the next quarter, the loss is less than 1 point. So we take no action and the gain or loss is $0. And here's just like the direct output of how did all 3 factors end up being. So what you see here is that it did end up being a light loss, as I said. But again, the important thing to realize is that maximizing these profit numbers every quarter is not what our goal is. The goal is, again, to reduce the beta decay. So when you look at it and you realize that these futures reduce the beta decay, the additional profit kicks in when we start rebalancing our portfolio. So then the beta decay would end up being much less than it would have been without hedging. And this benefit is where, what we're actually working on. So we're going to continue to develop this, and there's plenty of other things we can do with how we're hedging, where we can get it to a point where we also have profit here instead of, slim margins up or down. If we could actually get profit here as well, then reduce the transaction costs while we're hedging, that'd be overall more beneficial. But again, that's more long term. That's something we'll work on. So we do have to begin implementing it. So first step, we have to utilize the reinforcement learning model to find the optimal points that Johannon's been working on. So that would be our first step. Our second steps would be to, find code, or excuse me, make code that like properly calculates the beta of the new weights. That essentially means like, say if we have Apple at 1% and that's worth $10,000 out of, the $1 million budget, that stock's going to be worth 1%. But then if the gains on the stock were say $1,000, that stock's now worth 1.1% instead. So it's a pretty big difference of how the weights actually shift based on gain or losses. That's something that we need to consider when rebalancing and when we're calculating the decay. So we got to work on that first. Then we have to further implement what we have here and get it to be considered in the optimization function where we're rebalancing. So now our budget's being allocated between equities and contracts. So our decay has to be calculated to include that in it. So it's, all properly optimized and we have everything considered. And then finally, once we have these steps done, we can start observing the profit or loss of this new future simulator logic. So we can compare the profit or the transaction cost of the original simulator logic we have, and then we can shift it over and calculate the profit or loss and the transaction cost of the code with the future simulator implemented. And then the alpha signal framework, I'll give it to Shadid to talk about that.
Yeah, so I'm working on the alpha signal framework. So I tried implementing Finbert model for sentiment analysis, and the model provides predefined output in the form of probabilities for positive, negative, and neutral sentiments. We tried the model with some of the news articles of S&P 500 stocks, and it works well with the sentiment. But we are still figuring out how we can integrate the sentiment analysis that we get with the three-factor model that we have right now. And so the proposed framework for this is to scrape the most recent tweets from Twitter using for different tickers, and then we'll analyze the sentiments for these tweets using Finbit, and we'll map the results with the stocks daily open and close prices. Uh, we tried scraping the tweets using a 3P module in the Python, and it used to work well. I mean, I retrieved some thousand tweets in the last month, but right now due to some restrictions by Twitter, they are not allowing the third party tools to scrape the data. So right now we are looking for some more powerful tools where we can scrape the news articles or maybe tweets or some earning call transcripts, and we'll once we get this, we'll have our sentiments, and we can then pose the problem with the three factor model that we have. Yeah.
Yeah,
So
and then Johan, oops, sorry,
yeah, go
go
ahead.
ahead.
So updates on the reinforcement model is that bandit algorithm it actually works really well. I believe I did something around 100 iterations of factor exploration, and we got pretty good results. There are still some errors that come up over time, but essentially by asking you to explore more and more, we are able to find better and better returns. Now, the best return that you see right here is for the cumulative return, sorry, the net cumulative return of the factor models for 4 years in 4 years time, for a little more than 4 years. And what each iteration does is that each time it runs through and finds 10 new factors, and stores the data and recommends which one is a new one. And then whatever that was a new that is the new best factor, it uses that as the new base to explore better potential combinations of factor exposures. And it did the analysis, and this is what we are getting out of it. And our base is 100, so it has explore up and down to come and recommend these factors. What this means is that as we keep this in the repository to for future use, we could potentially find even better alpha providing factor models. So over to you,
Yeah,
Vincent.
and then we have pretty easy ways, so to speak, to implement this because I may have already touched on this, but say for the future summoner logic, we can utilize this instead of the current linear model to actually find the points where we want to be rebalancing because the 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 combination we're going to be using at the day one of year one may be different than what we're going to use in 3 years' time because